Welcome to the Buildings Canada webinar, Designing with Fire-Rated Glass, aimed to educate and inspire professionals within construction, architecture, design, engineering, property management, and renovation. Today's speaker is Tim Nass from SAFTI. So without further delay, I'd like to introduce Tim.
Hello and welcome to Designing with Fire-Rated Glass. I'm Tim Nass and I'll be leading you through this online course. As recently as 1980, the only available fire-rated product at your disposal was wire glass, rated up to 45 minutes, capable of compartmentalizing smoke and flames, the visual elements of a fire. Many of you are probably familiar with fire protective glass, namely wired and ceramic glass. At one point or another, you may have had a need or wanted to know more about fire-resistive glass or even specified it. Demand and use of this product continues to increase due to the fact that this building material has the unique ability to combine vision, fire, impact safety, sound attenuation, and many other features together in one glazing product. It brings light and transparency to areas that would normally be without usable light or vision because of fire-rated requirements, such as stairwells and parking garages. Today, it can be further customized to simultaneously protect against hurricanes, bullets, blast, forced entry, and more. Energy-efficient makeups for the building envelope and various decorative options are also common. Indeed, we are light years away from a time when your only option for fire-rated glazing products were limited to small wired glass door lights and openings. Today's breed of fire-resistive glazing systems are appropriately referred to as transparent walls. These transparent firewalls offer many safety benefits while enhancing the feel and efficiency of a building's interior. While this line of resistive products originated in Europe, North American-based manufacturing of this fire-resistive glass and framing systems have also contributed to the increased demand and use of this product. Prior to U.S. testing and manufacturing, these products did not have much of a presence in North America. At first, as with any new product that's imported from overseas, the high cost and long lead times made them less attractive to the architect, specifier, or building owner. That is no longer the case. Today, North America has vertically integrated fire-rated glazing and framing manufacturing that produces quality products at competitive prices and fast lead times. Designers can even collaborate easily with a local manufacturer on complex projects, using fire-rated in glazing areas and applications without limitations. While the demand for this product has increased, so has the confusion surrounding it. Fire-rated glass is first and foremost a life safety product, and its use is governed by the National Building Code of Canada. Beware of oversimplified explanations of fire-rated glass as thick versus thin or one product fits all approach, or even advertisements that tout unlimited applications. Between the types of products available today and the ever-changing code requirements, it can be difficult to keep up. This is where expert information becomes invaluable to architects, specifiers, glazing subcontractors, and code officials. Today, we are delivering this information to you, where by the end of the program, we hope that we have done a good job of explaining this so you'll be able to understand safety glazing requirements and how they apply to various fire-rated glazing products. Identify the difference between fire protective and fire resistive glazing based on the code and performance requirements of the application, not the manufacturer's product testing. Choose the correct and code-approved fire-rated glazing products based on NBC requirements and applications. Learn how today's advanced fire-rated glazing products can enhance a building's overall design and performance. So let's get started. Learning Objective 1. Understand safety glazing requirements and how they apply to various fire-rated glazing products. For well over 100 years, traditional wire glass was the only fire-rated glass product available. It was mistakenly perceived as safety glazing because the embedded wires gave the illusion of increased strength and impact resistance, when in fact the opposite is true. Wire actually weakens the glass, making it half as strong as ordinary window glass. It breaks easily on human impact, exposing razor-sharp wires that can trap a victim's limb in the opening and increase the severity of the injury. Alarmingly, traditional wired glass is still the most commonly used fire-rated glass product found in educational facilities. The Ontario School Board's Insurance Exchange, or OSBI, reported more than $5.8 million in costs for 114 wired glass injury claims from 2001 to 2015. In January of 2016, 16x9 reported on the dangers of traditional wired glass.
It's everywhere you go, and yet you've probably never noticed it. It's called wired glass, glass with wire mesh in it. It looks strong and has been used for decades in places we consider the safest, including hospitals and schools. But as 16 by 9 discovered, wired glass can be an accident waiting to happen, causing injuries that take people to the brink of death. Risks that have been flagged for years.
I was in Kingston, at a hotel in Kingston. It was second floor up one flight of stairs, and it was the door in the hallway. There was no push bar on the door, there was no handle, it was just glass window. And it actually had a push sign on the window.
22 years old, and without knowing it, Devin King was standing at the precipice of a life-changing moment.
I pushed it with two hands, and my right hand went all the way through the window.
The wired glass window in the hotel door gave way. The hotel claims that's because Devin punched it.
Yes, I was at a wedding and I was drinking, but I wasn't running. I didn't push the door any different than I did 10 times that day. Since it was wired glass, normally the window would shatter and break away, but the wire held the glass in place. It cut my artery, cut two of my nerves, and cut to the bone through my bicep, cut to the bone through my tricep, cut to the bone through my rear deltoid. It was, you know, flesh hanging off the bone.
With his artery severed, time became critical.
It was just like water coming out of a faucet, the blood pouring out of me. I yelled for my brother because he was in my hotel room, and I passed out from loss of blood and fell down the stairs. The paramedics came and they couldn't get a tourniquet around my arm, so they put me in the ambulance and sat on me the whole way to the hospital because there was no way to stop the bleeding.
Devin says he lost 7 bags worth of blood and was rushed into a 9.5-hour surgery.
My heart stopped 3 times at the table, so it could have easily stayed that way. I could have easily died there.
It would take roughly 250 stitches to patch together his arm. What could not be reassembled was Devin's life as he knew it before. He never regained full use of his hand. His plans of being a pilot in the military were dashed. Those dreams ended in that fateful hotel stairway.
I think it took me a long time to really comprehend how much this was going to affect my life. I was released from the military, had to find a new career, had to find new ways to do everything that I do because I wasn't able to use my arm for a long time, so it changed every facet of my life.
So the act of putting that mesh of glass inside, embedding that.
Engineering professor Doug Perovic says wired glass was designed to protect against fire, and does. But the glass has one serious flaw. It doesn't withstand any significant impact.
How long have we known that wired glass has safety concerns attached to it?
From the very beginning.
And we still installed it in public buildings?
That's correct. When it was first introduced as a commercial product, it was tested for impact, strength, and resistance, and it failed those tests. But because there was no other fire-rated product available, they gave it an exemption.
Hold on, because there was nothing better, they sent it through?
It was supposed to be only for a year or two.
That exemption was made in the US. But in Canada, we'd already been using wired glass for years and continued to do so. Today, you'll find it almost everywhere, in hospitals, hockey rinks, and schools.
The point that wire glass is half the strength of the regular glass that you start with. So by putting that in there, even though it looks all strong and great, you're reducing the strength of that original glass by about a factor of 2.
And Doug showed us why, using a high-powered microscope and a sample of wired glass.
So the wire is actually making the glass easier to fracture. And so when you put a bending force, let's say you're pushing on a panel of glass, cracks then start to form around the wire locations that wouldn't if the wires were not there.
Those dark edges you see around the wire are the points of weakness that leave it vulnerable to breaks.
You can visually see the gap that exists between there. It was never bonded fully.
This is a telltale sign.
Of an area of stress concentration, yes.
Ironically, this type of glass is referred to as safety glass. But Greg Abel of Portland, Oregon, begs to differ.
Do you consider wired glass a safety product?
Oh, absolutely not.
For 15 years, he's been pushing for stronger glass standards, ever since his own son was injured by it in a university gym.
The further I got into it, the more I realized that people had been being lied to by the impact qualities, and that all of these people that had been told that it was an isolated incident, that was not the case at all. There were literally thousands of young people being injured annually.
It became Greg's obsession to have the building codes changed. But the wired glass industry, which developed into a profitable business, wasn't about to go down.
So the risk to the industry was in the millions of dollars.
Correct.
This fight became about money.
It was always about money.
So safety was pitted against money?
Of course, without question.
Who was winning?
The wired glass manufacturers. It was our children that were losing.
But in 2006, Greg was triumphant. The U.S. updated its standards. Wired glass now had to meet a new, higher impact test. And traditional wired glass wasn't strong enough.
Wired glass is not allowed in any hazardous location, in any occupancy in the United States.
It was a voluntary standard, but in the years to come, it was adopted across most states. That meant any new construction would be forbidden from using wired glass if it didn't meet the standard. In Canada, nothing changed.
The longer they are able to delay the banning of wired glass in Canada, it amounts to millions and millions of dollars.
And so this seemingly innocuous glass continues to be installed and continues to injure and maim.
Today, is there a better alternative?
There are better alternatives, and they've been available for 10, 15 years.
And so why aren't we using those as the standard instead of wired glass?
The main reason is because it's not stipulated, it's not enforced by the building codes.
The Canadian National Building Code is what engineer Doug Perovic is referring to. It uses the Canadian General Standards Board guideline for wired glass, a standard that hasn't been updated since 1990. We wanted to know why and who's responsible for changing it. Even the manufacturers know it doesn't stand up to impact. Right on the box in bold letters, a caution. The wired glass should not be used where human impact is possible. Places like educational facilities. The Canadian Glass Association issued a similar warning and even supports updating the building codes. And yet, this is one of the places you'll find it most often in Canada. The Toronto School Board points out it has always been in compliance with the building and fire codes, even while using wired glass. It's just the wired glass standard hasn't been updated in 25 years. So why has it taken so long to update a glass standard while people are being injured? We wanted to ask the Canadian General Standards Board that very question. It sets the guidelines for wired glass use in Canada, guidelines that the provinces then adopt and make mandatory. But after 2 months of correspondence and asking for an interview, they declined, stating in an email that a committee is reviewing the standards for wired glass, expected to be complete in mid to late 2016.
After extensive review, The Canadian General Standards Board, or CGSB, released the new CAN CGSB Safety Glazing Standard 12.1-2017. Last updated in 1990, the 2017 version of the standard now applies to all safety glazing materials used in Canada, not just tempered and laminated glass. At the same time, CGSB also withdrew CAN CGSB 12.11 wired safety glass, which applied a lower 12-inch drop height or 100 foot-pounds used to assess wire glass as safety glass. Today, the scope, application, and labeling requirements of CAN CGSB 12.1-2017 have been aligned with ANSI Z97.1. It stipulates that all glazing used in doors, sidelights, and other locations where impact safety is required either meet the lesser Class B rating, tested to an 18-inch drop height or 150 foot-pounds, or the more stringent Class A rating, tested at a 48-inch drop height or 400 foot-pounds. To give you an idea of how different types of glass perform during impact, we performed the ANSI safety glazing test set to 400 foot-pounds of force. First, let's see how annealed glass, unfilmed ceramic, and unfilmed wire glass performed. The annealed glass, unfilmed ceramic, and unfilmed wire glass completely vacated the opening, unable to stop the impact at all. Not only that, but the glass broke into large shards that could easily cause serious injury. For the unfilmed wire glass, it exposed the embedded wires, capable of trapping a limb and causing further injuries. Manufacturers of wired glass and ceramics have made filmed and laminated versions that pass the 400 foot-pound impact test. Here's a filmed wire, filmed ceramic, and laminated ceramic performed in the same ANSI C97.1 test, set to 400 foot-pounds. While the filmed wire, filmed ceramic, and laminated ceramic all suffered breakage, they passed ANSI Z97.1 because there were no through penetrations. The film was able to withstand the impact and hold the pieces of glass together. Therefore, filmed wire, filmed ceramic, and laminated ceramic can be used in doors, sidelights, and other safety-rated locations. However, once it is broken, it must be immediately replaced. As you can see, it doesn't take much impact for it to break, and with the laminated ceramic costing upwards of $100 a square foot, glass replacement over time due to breakage becomes costly. Another option, which is a better option in terms of strength, durability, clarity, and affordability, is fire-rated tempered glass. Tempered has 10 times the strength of ceramic or wired, without the need for films or lamination, which makes it more affordable. It doesn't have embedded wires or amber tints either, giving it superior optical clarity. Here's how 2 layers of 1/4-inch tempered with a layer of fire-resistive intumescent performed in the same ANSI C97.1 test set to 400 foot-pounds. Not only does it pass the test, it survives the impact. This means that there's less breakage over time. In the event that tempered glass does break and needs to be replaced, it breaks into small pieces that pose no threat of injury. And since it costs significantly less than filmed or laminated ceramic, the replacement costs over time are reduced as well. Learning Objective 2. Identify the difference between fire protective and fire resistive glazing based on the code and performance requirements of the application, not the manufacturer's product testing. So, what makes fire-rated glass different from regular glass? In the event of a fire, regular glass will easily break or evacuate the opening, allowing smoke and flames to spread from one area of the building to another. Fire-rated glass is designed to stay in the opening during a fire, keeping smoke and flames at bay. More technologically advanced versions can even limit the passage of radiant heat, allowing for safe egress. By code, all fire-rated glass products used in the field must be tested, listed, and currently under the follow-up services of a nationally recognized testing laboratory. Manufacturers of fire-rated glass products hire the services of these test labs to test their products to certain standards and durations. If the product passes, it is given a listing. It is important for design professionals and code enforcement officials to understand that the listing agencies do not list fire-rated glass products in accordance with the codes or limitations on their use, but rather by what the manufacturer tested. Test agencies simply report the sizes and types of assembly in which the product was tested. For example, Test agencies often list ceramic glazing products in 60 and 90-minute sidelight and transom assemblies. These products are not permitted in opening protectives specified to have 60-minute or 90-minute under any building code in the United States. Accordingly, listings cannot be relied on for size or determining accepted code applications of fire-rated glass products. So when in doubt, refer to the NBC requirements, not a product's listing and/or paid advertising touting it as unlimited to ensure code compliance.
We'll explain this more when we get to the differences between fire protective and fire resistive glass. But first, let's examine how fire-rated glass is tested.
The fire endurance test determines the time a glazing product can withstand fire and extreme heat, with temperatures reaching in excess of 1,000 degrees Celsius. If the glass remains in the frame for the duration of the test, it is certified with the endurance rating ranging from 20 minutes to 3 hours. After the fire endurance test, the glazing test specimen is subjected to a high-pressure water stream from 20 feet away at 30 psi. ULC S101 requires no glazing loss. ULC S106 allows for 30% loss of glazing around the perimeter and 5% loss at center. All fire-rated glazing applications in Canada require a hose stream test.
Confusion still exists around the purpose of the hose stream test, especially when related to 45-minute glazing applications. But first, let me explain what the hose stream test is not. The hose stream test is not intended or designed to test the thermal stress performance of glazing materials. The hose stream test was developed in the late 1890s to measure the structural integrity of cast or wrought iron used as columns or structure of the building. If the cast or wrought iron failed during a fire, the building would collapse and cause death or severe injury to firefighters. It was never intended to be used as a performance test for thermal stress in glazing materials. The hose stream test is not intended or designed to demonstrate what happens to glass in an actual fire. 45-minute rated glazing is most often used in egress corridors measuring only 6 to 8 feet wide. No fire-rated glass manufacturer has demonstrated that any fire-rated glazing product can withstand the force of a hose stream at a distance closer than 20 feet. Not only that, but in an actual fire, firefighters will intentionally break the glass to gain access to the fire and effectively extinguish. Today, only the US and Canada require the hose stream test for applications under 60 minutes. In Europe and everywhere else, the structural integrity of fire-rated assemblies is measured by other test methods. As a result, many more high-performing and economical 45-minute glazing products are readily available in other major world markets, but not the US or Canada. The real safety concern here is limiting the passage of radiant heat, which is a requirement for all glazing applications over 45 minutes. The test for radiant heat is what differentiates fire-resistive glazing from fire protective. We'll go into detail later on, but first, let's discuss what radiant heat is and how the test is performed.
For applications 60 minutes and above, the glass is tested to ULC S101, the fire-resistive standard.
During this test, the prime source of heat, in this case test furnace, follows a fixed time and temperature curve designed to simulate a fire, where the temperature rises quickly and then gradually continues to increase. Thermocouples are placed on the surface of the glass on the non-fire side to measure the heat that is transmitted through the glass.
The average temperature calculated from these readings cannot exceed 139 degrees Celsius above the initial starting temperature, even when the temperature on the fire side reaches over 1,000 degrees Celsius at 2 hours.
What is radiant heat, and why is it a life safety concern? If you've ever stood in front of a fire to keep yourself warm, then you've experienced radiant heat firsthand. In small doses, it can be comforting and even nice. However, in large doses, such as heat generated by a fire, it can be extremely dangerous and even fatal. Radiant heat is invisible, extremely intense, electromagnetic waves that travel at the speed of light with little resistance from air. When these waves strike an object, they're absorbed and their energy is converted to heat. If the object is combustible material, such as paper, fabric, or wood, a fire will start when the material's ignition temperature is reached. Radiant heat is extremely dangerous to building occupants since it can quickly reach a level that causes unbearable pain, followed rapidly by second-degree burns, preventing safe egress. The critical level for unbearable human pain is 5 kilowatts per square meter, and the auto-ignition of wood combustibles is 7.5 to 13 kilowatts per square meter. To show the effects of radiant heat transmission through fire protective glass, here's a test that was conducted at a nationally recognized test facility in Texas. The test shows 3 monolithic 45-minute fire protective glazing products tested simultaneously. From left to right, we have ceramic glazing, wire glass, and heat reflective specialty tempered. So once the furnace is ignited, we can see conditions begin to deteriorate rapidly due to radiant energy. While these products are all tested to 45 minutes, it's clear that their inability to control radiant energy is becoming a factor. Less than 10 minutes into the test, the mannequin in front of the wire glass chamber ignites due to auto ignition. It's important to note that while these products allow energy to radiate through the opening, they don't fail because fire protective products are not judged on radiant energy transfer, rather whether or not they'll stay in the opening. Nearly 20 minutes into the test, the mannequin in front of the specialty tempered heat reflective product finally ignites. So what this test demonstrates is that all three fire protective products lack the ability to control radiant energy, however some perform better than others. Now that we've discussed the different ways that fire-rated glass is tested, it's now easier to understand the differences between the two types of fire-rated glass. Knowing the difference between the two will help you choose the appropriate and code-approved product for your application. There are two types of fire-rated glass: fire protective glass, also known as fire protection rated glass, and fire resistive glass, also known as fire resistance rated glass. Fire protective glass is tested to ULC S104 and S106 and is designed to compartmentalize smoke and flames, not radiant heat, and therefore subject to application, area and size limitations under the NBC. Fire protective glass is typically used indoors and openings up to 45 minutes and cannot exceed 25% of the total wall area, or as door lights in 60 and 90-minute doors, but is limited to 0.0645 square meters or 100 square inches. Sometimes it's used as exterior openings depending on fire separation distance. To learn more about the NBC requirements for fire-rated exterior openings, refer to Section 3.2.3.1 of the 2015 NBC. Examples of fire protective glass include fire resistive tempered, wire glass, ceramics, and specialty fire protective. Of all these options, ceramics are the most expensive, with the laminated version costing as much as $100 per square foot. Fire resistive glass is tested to ULC S101 and is designed to compartmentalize smoke, flames, and radiant heat. Fire protective glass is marked with a D for door or O for openings. Sometimes an H marking is added to show that the fire protective glass product meets host stream. The fire endurance rating is also indicated on the label. Unlike fire protective glass, there are no size or application restrictions for fire resistive glass. When paired with an equally rated fire resistive framing system, it can be used in wall-to-wall and floor-to-ceiling applications because it is considered a transparent wall, allowing for maximum clear views. Fire resistive glass is marked with a W for walls, and the fire endurance rating is also on the label. It may look like a window or an opening, but the code recognizes this type of material as a wall and can be used in place of gypsum or masonry where a 1 or 2 hour fire rating is required. But unlike gypsum or masonry walls, fire resistive glazing is transparent, giving the additional benefits such as vision, daylight, and direct lines of sight. Examples of fire resistive glass include fire resistive tempered and multi-laminates. During a fire, the intumescent inner layers expand and react to the heat to form a solid wall, effectively containing smoke, flames, and significantly limiting the transmission of radiant heat. This gives building occupants a safe path of egress or a haven where they can wait rescue. Learning Objective 3. Choose the correct and code-approved fire-rated glazing product based on current NBC requirements and applications. The code requirements for fire-rated glass are referenced in Section 3.1.7 in the 2015 NBC. Fire-rated glass can be used as vision panels, side lights, and transoms in fire door assemblies, exterior windows, and borrowed lights, as well as fire-resistive wall and floor assemblies. Table 3.1.8.4 in the 2015 NBC lays out the fire protection rating of closures. The NBC defines closures as a device or assembly for closing and opening through a fire separation or an exterior wall, such as a door, a shutter, wired glass, glass block, and includes all components such as hardware, closing devices, frames, and anchors. Another useful reference is Table 3.1.8.17, Restrictions on Temperature Rise and Glazing for Closures. This table shows how the code limits the amount all fire protective glazing tested to ULC S104 and S106, not just wired glass and glass block, due to radiant heat concerns. Ceramic glass, because it does not prevent the passage of radiant heat, is subject to the same size limitations. Note that fire-resistive glazing tested to ULC S101 is not subject to these limitations because it has been tested to limit the passage of radiant heat. For example, where the table limits the glazing panel in 90-minute doors in 2-hour firewalls to 0.0645 square meters or 100 square inches, 90-minute fire-resistive glazing tested to ULC S101 can be used to the maximum size tested. Fire protective glazing cannot be used at all in the wall. If glazing is to be used in this 2-hour firewall, 120-minute fire-resistive glazing tested to ULC S101 must be used. The requirements for 20-minute closures can be found in Section 3.1.8.12. The code allows 20-minute doors in 1-hour fire separations located between a public corridor and a suite, a public corridor and an adjacent sleeping room, or a corridor and adjacent classrooms, offices, libraries, and a Group A, Division II major occupancies. 20-minute closures can be found in 45-minute fire separations in buildings 3 stories or less. Sprinklers also affect the size of an opening protected by a closure. Section 3.1.8.6 Maximum Openings stipulates that the size of an opening in an interior fire separation required to be protected with a closure shall be no more than 11 square meters, with no dimension more than 3.7 meters, if a fire compartment on either side of the fire separation is not sprinklered. On the other hand, the size of an opening in an interior fire separation required to be protected with a closure shall be no more than 22 square meters, with no dimension more than 6 meters, provided the fire compartments on both sides of the fire separation are sprinklered. Note that fire-resistive glazing tested to ULC S101 is not subject to size limits. The code requirements for fire window applications can be found in Section 3.1.8.16. The code permits the use of fixed wire glass and glass block assemblies in 1-hour fire separations and must be installed in accordance with NFPA 80. However, the code also limits the maximum area of wired glass and glass block in Section 3.1.8.18 due to radiant heat concerns. The same fire window requirements and limitations apply to ceramics because, like wire glass and glass block, ceramics do not meet ULC S101, the fire-resistive wall standard. Note that the area and application limitation do not apply to fire-resistive glazing tested to ULC S101. For example, designers may incorporate glazing in 2-hour fire separations or exceed the glazing area allowed in 1-hour fire separations by using fire-resistive glazing tested to ULC S101. It's no longer considered an opening or window, but as a transparent wall. For these applications, it's important to remember that both the glass and framing need to be tested to ULC S101 in order to comply with the code. For example, using 60-minute fire-resistive glazing with standard hollow metal framing lowers the assembly rating from fire-resistive to fire-protective, which is no longer code compliant. But what about sprinkler trade-offs? There seems to be a debate on whether or not sprinklers can be used as a trade-off for fire-rated materials. In the U.S., after careful consideration and several code hearings, the International Code Committee has ruled that the presence of sprinklers does not eliminate the need for fire-resistive glazing, nor does it allow fire-protective glazing like ceramics to be used in applications tested and listed where fire-resistive materials are required, such as firewall assemblies. Sprinklers are active fire protection systems, meaning it needs a mechanical trigger in order to operate. While sprinklers are effective in controlling and suppressing fires, studies have shown that sprinklers can and have failed, according to the NFPA report, U.S. Experience with Sprinklers. The NFPA reported that majority of sprinkler failures, where sprinklers did not activate at all, occurred because the system was shut off. It also reported that when the system did activate, a majority of sprinkler heads were ineffective and the water did not reach the fire or not enough water was released. This could be caused by a number of factors, including manual tampering, lack of maintenance,
low water pressure, or damage to the system, which is a real possibility during natural disasters such as earthquakes. FM Global reported, sprinkler system breakage puts your fire protection out of service at the time that you need it the most. After an earthquake, the threat of fire is greater due to the increased presence of ignition sources and, at some facilities, flammable material releases. Knowing that sprinklers can and have failed, it doesn't make a lot of sense to rely solely on sprinklers to protect people and property in the event of a fire. The more sensible and safer way is employing a balanced approach by having both active and passive fire protection systems, like fire-resistive walls and doors that are built into the structure. These fire-resistive building materials create a fire barrier that form compartments or occupancy separations that contain flames, heat, and gases to the point of origin. By limiting the spread of fire with resistive materials, damage to the building is reduced and building occupants gain time for emergency evacuation or movement to areas of refuge. Unlike sprinklers, passive or built-in fire protection from fire-resistive materials works 24/7 without the mechanical triggers that sprinklers need, which makes it reliable and virtually maintenance-free. Learning Objective 4. Learn how today's advanced fire-rated glazing products enhances the overall building's design and performance. Today's advanced fire-rated systems are being used in applications well beyond the limitations of the fire protective products described earlier. These transparent walls are being used in projects without limitations in required fire-rated areas where vision, transparency, and daylighting is either a necessary or desired design element. Building occupants can have the peace of mind that they have the maximum protection in the event of a fire while still enjoying all the benefits that glass can provide. From a design standpoint, fire-rated assemblies can be specified to match the look of non-rated systems. This is important because fire-rated assemblies are often in close proximity or directly adjacent to non-rated assemblies. You can now achieve a seamless, uniform look throughout the building. And US-made fire-rated glass and framing can come in infinite makeups, and the accompanying framing systems have the sharp, clean edges of popular aluminum and storefront systems, with a multitude of finishes including clear, bronze, and black anodized, high-performance coatings, and even decorative metal or wood cladding. There are several studies on the benefits of bringing natural light into any space, and that's why glass has become such a popular building material. In schools, students learn faster and teacher morale improves. In hospitals, patients recover faster and lessens depression. In the workplace, employees are more productive. And in all of these facilities, having natural light can help decrease energy costs. In areas where fire ratings are required, fire-rated glass can provide all the benefits that glazing offers, allowing natural light into a space or sharing artificial light between spaces, all while complying with code. Whenever extensive amounts of glazing is used to bring natural daylight in, letting in heat becomes a concern as well with regards to occupant comfort. Today's fire-rated systems can be combined with low-E or other high-performance glazing to achieve a prescribed solar heat gain coefficient, U value, or any other energy performance requirement. Sunshades can also be incorporated directly into fire-rated systems to minimize glare. Recently, USA-made fire-rated glass and framing have been added as approved components in NFRC's CMAST database, making it easier for designers and building envelope consultants to simulate fire-rated glass and framing assemblies with high-performance glazing to meet a specific energy performance requirement. 1- and 2-hour stairwells, once relegated to the back of the building and used for emergencies only, are being transformed because of fire-resistive glazing. Normally dark and windowless with nothing more than a small door vision panel, these stairwells could become a prime area where building occupants fear being attacked or mugged because they're closed from view. Using fire-resistive glass brings a feeling of openness to these areas with full visual access while still meeting the ULC S101 requirement. Having light flow freely into these stairwells also encourages its everyday use. Today, stairs are being placed in high traffic areas like lobbies or main entrances to serve as traffic enhancement and promote better health through physical activity. Just 2 minutes of stair climbing a day can prevent the pound of weight that the average American adult gains each year. In the U.S., the General Services Administration, or GSA, is leading the way in reinventing stairways to make them more appealing with a policy to promote stair use in all 8,600 federal buildings. The GSA's architectural and interior design standards require the location of stairs within buildings should encourage their use in lieu of elevators to the fullest extent possible. This will reinforce the recognition of sustainable energy conservation. Today's laboratories, science, and manufacturing facilities aim to enhance collaboration. Instead of solid walls separating the lab, offices, and conference rooms, glass walls enable people to see into and out of these areas. In areas where oxygen tanks are stored or other flammable materials, fire-rated glass can be used to meet building requirements and allow occupants to see inside the space. Fire-rated glass can also assist firefighters to visually assess the situation in the event of an actual fire. With glass elevators becoming more popular than ever before, vision and transparency can be extended to the elevator enclosure as well, using fire-resistive glazing. Parking garages also get the benefit of vision and transparency when fire-resistive glazing is used. Cars, because they usually require fuel, can be considered a combustible material and a potential fire threat. Because of this, fire-resistant materials are either required or recommended to separate the areas occupied by people and vehicles. Using fire-resistive glass gives the added benefit of a clear view. While most fire-rated applications are still found inside the building, we are seeing more exterior applications of fire-rated glass, especially in cities such as Toronto, Vancouver, New York, San Francisco, and other densely packed areas where buildings are in close proximity to property lines. In these situations, the concern is to keep the fire from spreading from one building to the next without having to sacrifice clear views. When fire-rated systems are used on the exterior of the building, the expectation is that they will perform like the rest of the building envelope. Because of this, today's fire-resistive curtain walls undergo dynamic curtain wall testing to ensure that the system is air and watertight. As part of the dynamic testing process, today's fire-resistive curtain wall systems have been tested for structural performance, seismic and wind-induced interstory drifts, thermal cycling and condensation evaluation, and interstory vertical displacement. Fire-rated glass can also be combined with security glazing to form a single assembly that protects against fire, bullets, blast, and forced entry. In the past, the fire-rated system, which was usually wired glass, was placed alongside the ballistic, blast, or security-rated system, which meant two different manufacturers and two separate installations. Today, designers can have a single, multi-functioning system that's provided by one manufacturer, tested and listed to do the job that's required. These fire-resistive and hurricane-rated systems have complete Florida approval numbers, Texas Department of Insurance approvals, and UL certifications. We are seeing the need for fire-resistive and hurricane-rated systems in Florida, Texas, and even New York and New Jersey. Decorative art glass can be added to fire-resistive walls to bring a unique design element to any space where fire ratings are required. Fire-resistive but glazed transparent walls are also available for the ultimate clear views without the need for intermediate vertical mullions. The latest innovation in fire-resistive glazing technology is the development of fire-resistive glass floors, rated up to 2 hours. Traditionally, concrete is used between floors for fire resistance. The development of a fire-resistive glass floor with non-slip walkable surfaces enables light to penetrate further into the building while meeting all the required fire-rated requirements. Both the fire-resistive glass and structural steel framing grid are manufactured in the U.S. Modular, completely top-loaded design provides architects and installers with a turnkey solution that results in better coordination, less labor, and more savings. The individual fire-resistive glass panels are available in large sizes for both fully supported and butt-glazed floor assemblies. It's tested with a load of 100 PSF to meet most loading requirements and available with load spans up to 40 feet. Additional engineering can be done for longer spans. And this concludes our program, Designing with Fire-Rated Glass. I hope this information is useful and gives you the confidence to use the appropriate code-compliant product for your application, and possibly use fire-rated glass and framing in applications you've never dreamed before. Thank you very much.
First question is from Ben. Are there any insurance companies that offer rate reductions when fire-rated glass is installed? Not that I'm aware of, Ben. Again, this is typically a code-driven product, so I'm not sure that the insurance companies are having any discounts to the building owners or developers for incorporating fire-rated. Okay, next question. I'm not sure if this webinar provides 1 hour learning objective. If it does, would you issue a certificate? It does carry continuing education credit for life safety and wellness. So we will make sure that once you're registered, you will receive either written or electronic certificate. What is the price per square foot for the typical 1 hour fire-rated glass assembly? That varies based on size of opening, configuration. Certainly the economies of scale come into play earlier with fire-rated than they do with perhaps non-rated. I would say somewhere in the neighborhood $150 to $200 a square foot US. I understand that ULC S101 is the test, but do you have listed ULC assemblies as part of your 60-minute ratings? Yes, everything that safety provides is tested to ULC standards or through Intertech, and those are also to the Canadian standards. How does sprinkler protection glazing compare with fire-resistive glazing? Typically what they do, Samuel, is they will combine either some fire protective rated assemblies or non-rated glass, laminated, and aluminum framing, and rely on the sprinklers to provide the fire protection. Fire-resistive glass will actually compartmentalize not only the visual elements of the fire, but also prevent the transfer of radiant energy that's generated from the fire. The code is very specific. They don't want the sprinklers to reduce radiant heat flow because they're not 100% foolproof. So these fire-resistive products actually stop radiant heat from penetrating through the glass and the framing for a prescribed period of time. Currently, the highest rated product is 120 minutes. Is Safety First considered a consultant, supplier, or subcontractor? Safety First is a manufacturer and a supplier of fire-resistive glass framing and entrances. Certainly, we provide consultative selling services to the architectural community, to the glazing subcontractors, as well as to building owners. The big thing is these products are certainly code-driven, but they are more so application-driven, meaning we have to look at what it is you're trying to accomplish before we can recommend the appropriate product. What types of facilities do you see the 1 and 2 hour fire-resistive walls used the most? Currently, I would say the institutional market segment, that would be universities, colleges, labs, any kind of higher education facility. We're also seeing some of these products being used in the security or protection market segments, hospitals that are run by the Army, military facilities. Detention facilities are becoming a big market segment as well. Again, the ability to open up the space, incorporate natural daylighting without incorporating wire glass or any of the other antiquated products is where you're going to find the fire-resistive products. Is this product manufactured only in the US or Canada as well? Currently, we manufacture in the United States, but we do obviously service the entire country of Canada. However, our manufacturing facilities are located in Merced, California, about 2 hours due east of San Jose. To my knowledge, there are not any Canadian-based manufacturers of these products. We can provide you a transcript of this presentation. We can email that to you. So if you'd like, we can get that information to Stephanie, or we can mail it out with the email list that we have from the attendees. You can watch the presentation again on our website. You can select either the US or Canadian version. Lead time at least 12 weeks. It depends on the products, typically 8 to 10 without doors, 10 to 12 with doors. We usually allow between 2 to 4 weeks for shop drawings. Are the fire decorative glass shown in the webinar a lamination with an inner layer, or are they 2 pieces of glass separated by airspace? The examples that you saw, actually, Wilson, the digital image was printed on the surface of the glass. So a digital printer is certainly something that would allow you to put any type of design on the surface of the glass and then incorporate it directly into the fire-rated or fire-resistive glass. The Superlight 2XL product that we offer does allow for aftermarket films to be applied to create a translucent effect or any aesthetic intent you're trying to accomplish. If sprinkler water hits hot panels, will they crack or shatter? The answer is yes. Typically, thermal expansion and contraction will create glass or will allow for glass to break. Ceramic glass is the exception in the sense that it has it's in a constant state of neutral tension, meaning it doesn't expand or contract when it gets hot. So that is what's unique. It's a unique feature to ceramic glass and why it was first introduced in fire-rated applications, because it wouldn't break. Can this be used as an existing building retrofit to be used as new storm windows on the exterior of existing heritage buildings to achieve fire protection? The answer is yes. These products can be used in retrofit applications. They can be used on the exterior of the building. And we can leave or not disturb the existing historical products that are currently in the opening. Where can I find that sprinkler failure report? That was something issued by the federal government in the United States. However, I believe we can find the publication where it was first printed, and we can provide that for you. What is the maximum size limitation of the butt glazing on the fire-rated 120-minute floor? I believe our maximum dimension is 87 inches, and it is dependent on butt glazing, it's different for fully captured. That information can be found on our website. Is 2 to 4 weeks for shop drawings in addition to the minimum 8 to 10 weeks, or is that included? The 2 to 4 weeks for shops is a separate time frame. Once we've got approved shop drawings in-house and we're ready to release the product for fabrication, then it's usually an additional 8 to 10 or 10 to 12, depending on the product that's specified. Will the integrity of the glass be compromised if the glass is etched? Can a frit be applied to this glass? The Superlight 2XL, absolutely. You can apply an etch or a frit to the glass without compromising its integrity. Any additional questions? Are you finding acceptance of your products by local authorities having jurisdiction in Canada as a fire-rated product? Yes, the Canadian authorities have accepted this product because, again, it does carry Canadian certifications. So the listings, whether it's through Intertech or Underwriters Laboratory, is for Canada specifically. So yes, these products are widely accepted. For exterior applications, will both panes be fire-rated glass? So what we do in exterior applications is we will provide our Superlight 2XL, which is 2 pieces of 1/4-inch tempered glass joined together by a super spacer. We then take an intumescent polymer and we fill the airspace that resides between those 2 lights of glass. That's what makes it a fire-resistive product. We then add an additional airspace, and then we can incorporate any type of coated product into our fire-resistive unit. That allows for aesthetic continuity from the exterior. The fire-resistive product looks identical to the non-rated product, and therefore it's indistinguishable to the building occupants. The only thing that would indicate that it is a rated product would be the glass bug that resides on the surface of the glass to indicate what performance levels you're complying with from a code standpoint. Again, the big thing with fire-rated, they're code-driven products, but more so application-driven, meaning we have to determine what it is you're trying to accomplish from a code standpoint as well as an aesthetic standpoint. And then we can assist you in product selection, how you can comply with code and still achieve what it is you're trying to accomplish from a design standpoint. It's important to note that, again, as we stated in the presentation, that these products are fully tested and listed for the Canadian market, not only for fire rating, but also for thermal, air, water, structural, both statically as well as dynamically. I should point out that we do have a local representative in Canada. His name is Richard Verdun. Richard is located in Ottawa. He has agents across the country that assist him in his efforts. He does an excellent job working with the architectural community. He's heavily involved in the Canadian Glass Association. Works closely with glazing subcontractors. So Richard is an excellent resource. His contact information can be found on our website. Again, I should point out that our lead times are also predicated on product. So the systems usually require 8 to 10 weeks, but some of the loose light, bar light products, the monolithic products are available much faster.
And that's the end of this webinar, Designing with Fire-Rated Glass. If you missed any of today's webinar, it will be posted on buildingscanada.com under Available Webinars. Make sure that you bookmark buildingscanada.com as your go-to resource for accredited expert webinars, innovative product showcases, breaking industry news, white paper reports, upcoming events, and more.